Okay, so part two, talking about global warming and global change. So with global warming, we're going to get a rise in sea levels. Most of the heat that comes from global warming is actually captured by the oceans. So with a rise in sea levels, that's going to happen because there's more heat in the ocean. Heat expands, so the oceans are getting hotter and they're expanding. So this is something quantifiable. I'll show you a graph. What that causes, that expansion and that rise in sea level, is going to be more water contamination, mostly due to floods. So we're going to get areas that become completely inundated with water. If there's any pollutant in that area, it's going to mix with that water. They're usually soluble in water, and so they're just going to be able to move freely, those pollutants, throughout that inundated area, which means it's just covered in water at a certain period of time. And then you're going to get more extreme weather events. We talk about this every single unit. With more heat in the system, there's going to be more energy in a system. With more energy in a system available, there's going to be more of that energy to pull from for weather events, such as like hurricanes, cyclones, those things. So a hurricane is going to be like a cyclone event, and that's going to get more extreme due to more heat and more energy. Then we're also going to get heat waves. This isn't really due to the rise in sea levels, but that's more due to just warming. So Phoenix had a really, really bad heat wave this year. Pretty much the whole like desert arid area of the United States has a really, really bad heat wave this year. You're going to get drought, higher frequency of intense storms. Tibet, we might talk about this later, but Tibet actually had the the hottest decade in the last 1,000 years. So that's going to affect the climate all around, not just in Tibet, but all over the world due to the hydrologic cycle. Animals are going to move, all sorts of things like that. You know, there's all sorts of factors that change when you change an environment. So we kind of went over that last lecture with changes in the environment or in the ecosystem. Um, and then, like I said before, you're going to get higher frequency of more intense storms. Okay, so here is that data I was showing you or telling you about. Here's the sea level change in millimeters. 1 millimeter of sea level change is a very, very significant amount of change if you want to think about it. There's thousands, hundreds of thousands of gallons of water in the ocean. So every time, it's kind of like with plate tectonics. Every time you get a small movement of all of that mass, you're going to get a crazy amount of energy change in those systems. So that creates a lot of instability. So right here it says the ocean's rate of change is about 3.4 millimeters per year. So that's quite a bit. That's pretty significant. And as you can see, this is just from 1995 to 2014, it looks like, or 15. Either way, from 95 to 2015, we got an increase in sea level of about 80 millimeters, which is a lot, considering all of the oceans. That went up 80 millimeters. So that's an insane amount. It doesn't seem like a lot now, but if you think about it in the context of the whole Earth, it's a crazy amount. The amount of energy needed for that to happen is ridiculous. All right, so here's just another good graphic. It correlates really well with that 1990 right here. We saw that sharp uptick. Same thing. And so this area right here is kind of like the surface of the ocean. It's 0 to 700 meters. But you still see an increase in 700 to 2,000 meters, and even the land and the ice and the atmosphere increased. So what this model is showing you that sea level sea level is increasing and sea heat is increasing, and that ocean is where most of the heat we're going to see most of the heat increases because this is the land right here. It doesn't increase all that much. But oceans take a little longer to heat up, and they have more specific heat, so they have more potential for heat energy. So that's why we see this crazy change here. Right here, this is our fake global cooling event from 1945 to about 1970. Really, what this is caused by is an increase in aerosols in the atmosphere. So with an increase in aerosols in the atmosphere, we get an increase in reflection. That albedo that we were talking about, which is kind of like how the Earth maintains homeostasis through heating, the amount of reflection that's happening, that changes as well with aerosols. So in this time period, we had a lot of aerosols. That's that's not just things that you spray into the air, but it's also like just like dust from the dust bowl. That's a big aerosol. So it's things like that that go into the atmosphere and they cause more reflection. So you're going to get cooling events with aerosols. So I'll talk a little bit more about that. So 1970s global cooling. I put it in parentheses in quotes because it's not real. We did have a cooling period, but we know why it happened. It isn't a natural event. It's human caused. So to use a recently revitalized term, the 1970s global cooling, it's fake news. People nowadays use this 10 to 15-year time period to try and discredit all of the hundreds of years of global climate change data that we have. So it's nitpicking data, and it's not nitpicking it scientifically. It's nitpicking it really ignorantly. It's an uneducated way of looking at things. So there was a cooling trend from 1945 to about 1970. But this was due to the aerosols that I was telling you about in the atmosphere. They directly reflected the sun's rays, so that directly affected the Earth's albedo, which is the ability to reflect rays and its homeostasis with heating and cooling of ecosystems. Also, these aerosols kind of cause more intense cloud condensation formations, so that's going to add to reflection as well. So we know that clouds also add to reflection of solar UV radiation. So that's why we got that small cooling period. And the funny thing is, about 1975, this cooling period stopped. You know what we stopped using? Aerosols. So there's the evidence right there for you. So during this time, only about 10% of the scientific community was actually worried about a cooling crisis. The other 90% was focused on warming trends due to greenhouse gas emissions. So one of the earliest greenhouse gas emission reports we have is in 1959, and they said if we don't try and curb greenhouse gas emissions, we're going to see an increase in warming trends in the future. And we are now in the future, and we have seen an increase in warming trends. So it's almost insane not to look at this information and realize what's happening. So there's a really good book, 2052, by Jorgen Randers, and it's a sequel to the book Limits to Growth. I encourage you guys to read both of these books. Limits to Growth is just a whole bunch of MIT scientists, which are basically the smartest people in the planet, and they got together, created this thing called the Club of Rome, which is a think tank of all the smartest scientists getting together, looking at models, predictions, and the book 2052 is kind of just adding to this book, The Limits to Growth, saying that we're going to hit a certain limit to growth, our carrying capacity, and along with other like global climatic changes, we're going to get this like crisis event in around 2052. So, well, don't freak out because that doesn't mean it's going to happen, but that just means that at about this time we're going to start seeing some crazy stuff go down. It's postulated that at about 2052, over 75% of the Earth's conflicts are going to be over access to clean drinking water, and that has almost everything to do with climate change. We talked about the pollution, we talked about the drought, we talked about all that stuff. So it's all coming together a little bit for you. And then just look up the Club of Rome because it's a really good organization, just kind of trying to focus on keeping the world stable. All right, so a lot of scientists expect dire consequences from these warming rates. This isn't new. Like I said, it's been in the scientific community since the 50s, probably earlier than that, but this is like one of the first recorded scientific papers about warming trends. So we're going to get diminishing resources. That's due to trees getting cut down, less available area for us to habitate due to rising of sea levels, all sorts of things. but we're going to get more starvation, more pests with that larger insect range. With this warming trend, we're going to get more pests. So that's going to decrease crop growth, really. We're going to get higher onsets of disease events because of those mosquitoes and all sorts of other vectors. A lot of times, like standing water holds a lot of disease, so we're going to get more of that with more flooding. And then we're going to, with that increase in CO2, we talked about ocean acidification. One thing I want to talk about is an increase in smog levels. So this new administration is kind of going back towards coal for some reason. It's not a sustainable fuel. It's first of all, it's a non-renewable resource, so we only have so much of it. That's the first thing. The second thing is it increases smog levels drastically. So smog levels are going to increase respiratory illnesses, and this is today. So currently, today in 2017, 2/6 of our deaths in the world are caused by pollution, and 2/3 of those 2/6 deaths are caused by air pollution, and that is smog. So when you think of like Beijing, when they have these horrible smog problems, a lot of those people are developing illnesses that end up making them die. So the reason why we're going towards coal doesn't make any sense to me, ecologically, scientifically, even economically. These are probably things that you guys should research on your own, but I'll kind of hit it a little bit here. So cutting pollution actually saves money. This is statistical. When you reuse and recycle your products, it's more cost effective. So cost effective business strategies are going to make you get more money. Working on emissions regulations creates jobs. This is also something that we know happens. It opens up the market, which expands the economy. You're getting more variation in the economy, which, just like biodiversity, more diversity in the economy is a good thing. You have more avenues for growth that way. So essentially, an increase in warming can severely damage the economy. First off, only going towards one energy marketplace will damage the economy. That's going to be a monopoly. With more variation in the economy, you're going to get more growth and more ability for growth. So that's just one reason why it's going to damage the economy. Look at significant weather events. Puerto Rico, think about that. Like how much money we have to spend now to fix the infrastructure of Puerto Rico because people weren't admitting that global warming is causing more climactic events, and people weren't getting ready for this event. And that's in Houston and Florida as well. So here's just a few extra things. Like I said, Tibet, it's had the hottest decade in 1,000 years. This isn't just in America. Glaciers are receding at greater rates than historic data tells us, so the rate of glaciation melting is going faster than it ever has before. The annual melt season for the Antarctic Peninsula has gotten about 2 to 3 weeks longer, and with that elongation of the melting season, we can see a future collapse of the Antarctic ice shelves. We've already seen these shelves start to collapse. It's going to happen. With more heat, ice is going to collapse and turn into water. So with a lot of those shelves collapsing, it has the potential for a 19-foot sea level rise. So think about that. We have an 80 millimeter sea level rise, and we're already seeing the repercussions. Okay, so 80 millimeters compared to 19 feet is like this compared to this. It's insane. So 19 feet would be devastating to most coastal areas. They're going to get flooded, and then storm surge distance capabilities will increase with more water, more energy in that system. And so, as we know with that severe weather unit, storm surges are kind of like the worst part of the hurricane afterwards because they destroy a lot of the infrastructure. So these are just it's a lot of information to think about. I encourage you to go on your own and research this topic because I can't make you educated on this topic in 30 minutes. You have to read. If you don't read, if you don't read all of the material and get all of the information from both sides, then you can't make an informed decision or opinion based on these topics. And I want you to kind of use that little motto for your life in general. If you aren't willing to look at the other side of things, then you cannot make an informed opinion about that topic. So just think about that. Try and stay informed. It's really important, and we need an informed society, and you guys are the ones who are going to do that. All right. So let me know if you need anything. That's it.